Hi everyone, welcome back to the channel. On this video, Cian, one of our structural engineers here, is going to run through using Idea Statica and designing a precast concrete panel, a header beam with some M&E openings. It's an excellent video and well done, Cian, and I hope everyone enjoys. Thanks for watching, guys. Don't forget to like and subscribe.
Hi everyone, my name is Cian. I'm a structural engineer here at Structural Innovate, and today I'm going to be doing kind of a quick walkthrough of how we would approach the design of a concrete header beam over a window for a number of M&E openings. Before beginning the design of the header, I just wanted to kind of show you the information that we receive and how we go about kind of pulling dimensions off to input into our Idea Statica model. So what I've kind of shown here is just a typical window header. And you can see we have these M&E um, circulation or ventilation units that need to puncture through our headers. Now I've just switched this on here so you can see the type of unit that we're dealing with, but I'm going to turn it off here now so we can get a clear picture of the coordinated openings. So these are the openings we've agreed upon. So what I need to do now is just kind of start putting off our dimensions. So you can see our header is 525 millimeters deep, and it's going to be a 200 millimeter wide section. So I'm just going to pull these dimensions off here now, and we can begin putting them into Idea Statica. So I've just brought a quick snip in here to sketch to show you our kind of design assumptions on how we input the header into Idea Statica. So we always assume that our headers are simply supported. Now, Idea Statica kind of needs a bearing amount either side. So what we assume and what we found from our experience is that 200 millimeters either side with a pinned connection works the best for us. So I'm going to go in now and get our loading from the tributary area above on the flat roof section. So we have our precast panels, our screed, and our live and dead loading on the flat roof section. So I've got a very simple MUDL loading here of the slabs sitting on top of the header. So I have a dead load of 50 kilonewtons a meter. It's quite a heavily loaded roof section here because there's some solar panels on them. And I have a live loading here of 12 kilonewtons a meter. We have our loadings and our dimensions. We can go ahead and open up a concrete section in Idea Statica. So I like to start off with a kind of a preset one with an opening just to get the design going. So I'm going to click create on that. So here is kind of the preset beam. And I like to start on the right hand side and just work my way down slowly through all the different elements. So if you can recall, we start with our member. Our member was a rectangular section. So we click the plus symbol, rectangular section, and he was 525 millimeters high and he was 200 millimeters thick. And the concrete grade on this project is going to be C4050. So I'm going to set the concrete grade to that. The overall length of the member is 3 meters in the opening, but we have our 200 millimeters either side for the bearing. So we're going to set him to 3.4 meters. So there's our open, our header. And there's a section here that you can trim it. Ours isn't going to be trimmed, it's going to be ended either end. So the beam is going to stop. And the next thing we can go looking at is our support conditions. So no support conditions are inserted at the moment. So I'm going to go up here to model entity and add a model entity. And I'm going to insert a point bearing plate. This is going to be our pin support. So you see it already sets up here in the far left hand side, which is fine. It's exactly where we want it. And Let's put down through the settings here. It's 200 millimeters wide. As we said, that's our design assumption for simply supported. And I'm going to just copy that element. So now I have two support conditions, and I'm going to set him, instead of being from the beginning of the beam, he's now going to be located at the end of the beam. So you have your simply supported header, and we can start looking at our load conditions. So as you see, there's already one's kind of set up already, but if you wanted to add any more, you click the plus button. So you have point loads, line loads, surface loads, and self weights. So we're actually going to click on the self weight here as well, so that Idea Statica takes account of the self weight of the header. So if we go back up to the line load here, it's already been put in. This is going to be, I'm going to set this load case 1 is permanent, so that's going to be our 50 kilonewtons a meter. In the minus direction, so it's acting down. Load case 2 is going to be our variable or SLS case. So I'm going to set him to minus 12. That's the loads that we got from our tributary area on the flat roof. So we have our two load conditions, our live and dead UDL set up, and we can start looking at our different combinations. So again, there's going to be preset ones here, but you can come in, you can click the little pencil button here to edit them. So we have ULS, quasi-permanent, and characteristic. So I'm just going to set the live load 0.6 on the quasi-permanent. So they're good to go. So our ULS 1.35, dead 1.5 live, and our SLS is 1 and 1. So we'll click OK on that. SLS combination, so that we already edited those, so they're okay. Put them all into one go. And now we can start looking at our rebars. If I just make it 3D. So you can see the way the preset has come in. There's a bundle of bars at the bottom and there's a bundle of bars at the top. We just want to run 2 bars at the bottom and 2 bars at the top. So we can come into our group 1, highlight the 4 reinforcement members at the bottom, and they're the 20 millimeter diameter. And we want to go and set the number of layers to 1. So there you go. We have 1 at the bottom. Same again. Back to the top bundle. Again, number of layers 1. So now we have bundle bars in the top and at the bottom, and I'm just going to up these to 16. So we need to look at our anchorage type, and these are just going to be basic anchorage. They're going to be straight bars. As we go down through the different settings, click down through them, they all look okay. These are the locations. Now our concrete cover, and again, this can be user value. So I'm just going to set this to 25. This might vary from project to project or where the beam is located. Again, I'll just set the bottom bar to 25. So as we go down, we have our we can go into our cages down here. So if I go into the first set of rebar properties here, and again, if you want to add any more of these, you just click the plus button up here and you can pick your stirrup group. I'm just going to use the preset one that's put in. So I'm going to set our stirrups to 8 millimeter bars, and the shape, I'm happy enough with the shape that's in there at the moment. That's the type of bent bar we'd be using. But again, you can change your shapes depending on your particular project. So it's just a few variations, but we'll stick to the one that we want. And you can also change how it's closed at the end. Again, just clicking through the settings, but I'm going to stick to the bent bars that we'll be using. So the set out of the bars, the way it's brought in here at the moment is there's a different measurement for kind of each stirrup in the beam. So the first one you can see is 100 millimeter space, and then there's 6 of them at 200 millimeter space, and then there's 20 of them at, as you can see them kind of narrowing down a bit there. There's 20 of them at 150 millimeter space, and so We like to keep things uniform, so I'll be just deleting all of them, putting in an A, and then I'll be setting them to 200 millimeters. So that will automatically set at about 200 millimeter centers throughout the beam. And as you can see here, there's kind of one missing at the front. I can quickly just shove in a bar at the start there, and it'll automatically recenter them. Again, this makes it easier as the design goes on. We might have to drop that down to 150 millimeter centers or something like that, or even 100, and it'll update them correctly. So I'll put in back to 200. So now we can start adding in our openings. So we need to put in another model entity. You can see here we have a couple of different options, but we want the option to set as opening. So it's brought in an opening and it's positioned it here in the middle. But again, we can come up to our opening here and then we can start modifying it. So ours, if you recall, it was 500 millimeters wide and it was 200 millimeters high. So that's our rectangular opening. Now the master point here for the position is how you set it out. So I like to set mine out from corner to corner, so 1 and 1. So the master point here, I'm going to set it to be 1. And the insert point of the opening itself also set to 1. So you see it's going to set itself over that 1 and 1 position. So now recalling kind of the dimensions we took there from the ISC model, we can set this fella out. So the X direction, which is along the length of it, he was 460 millimeters, but we add on the extra 200 again because of the bearing support on the left-hand side there. So 660 millimeters, 0.660. So that's going to move him along to where the opening is in the X direction, and in the Y direction, he is 155 millimeters. So there's our first opening in there. You can see it's automatically updated the stirrups around it. So that's our first M&E opening. We need to then add in the second one. So again, I'm just going to copy that opening 2, rectangular, 0.5, 0.2. Again, the master point is 1 and 1, so we just need to change our X and Z directions again. So our X dimension we're going to put in is 2.265. And we don't need to change our Z direction because they're both on the same level. So there's our 2 openings in. And now we can just run the analysis again to see how we get on. I'd be interested to see how the openings fare out without any trimming. So you can see we passed in ultimate limit space, but there's a stress limitation for our C2 combination. So as you can see, if we go into our check, we're going to be getting a lot of high stresses around the corners of those openings. So if we go to our stress limitation, get down to our C2, you can see here right at the corner, we're exceeding our stress limitation on the corner, which is what's to be expected. To rectify this, we can go back to our design and we can trim these openings. So there's a handy preset already in Idea Statica. So you open up a rebar assembly and we can set the cage that goes around our opening. So see here it's brought in a preset trimming. Now there's too much going on here, so we're going to scale that back. So 8mm diameter bars, we're going to have 2 layers. So that's one at the front face, one at the back face, and we're going to have 1 bar in each layer. So there are the horizontal and verticals, and we have the diagonal trimmers next. Again, just one of those. So you can see it's already trimmed the opening, and if I switch to the 3D, you can see it's at the front and the back face. So I'm going to then copy that cage onto the other opening as well. Set in from the master point here to opening 2. So we can run this now and see how the beam fares out. So you can see by trimming the openings there, everything seems to be checking out. So we can go into our check again, and we can just kind of flick down through here and check. So you see that we brought that within its limit state. And you have your different kind of um, results up here. You have summary, strength, anchorage, stress, crack widths. So you can flick down through these, see how your beam is reacting, see are you happy with the way things are and the results you're getting. And you can then generate a report at the end of it. The one we like the most is this reinforcement scheme. So this can be sent to detailers, and it gives the general layout, concrete grade, type of steel, where the bars go and their sizes. And this is a very clear kind of diagram that we can send on to any detailer who is detailing that concrete header. So that is the kind of quick overview of the general approach that we would take when designing a concrete header for M&E openings. Thanks for watching.